Hello everyone, good morning. Welcome back to this part 2 of Zoho IoT 101 series. This is connecting your devices. Those who had missed the part 1, so this happened on October 7th. This was a high level overview on Zoho IoT. We have planned to upload our video on YouTube and other channels. We'll share that to you. So welcome you to this part 2. And a quick intro about myself. I am Jagan. I head Zoho IoT, and I have been with Zoho for over 23 years, extensively involved in product engineering, product management, and customer implementations. So today I have my teammate Renga as well with me. So who is a developer who would be taking you through some of the development aspects of the demo. And so this is going to be today's agenda. So first is a little recap overview about Zoho IoT. So what, why, and things. And then in general, IoT technology stack. What are the technology involved in that end to end? And then the core functional modules and architecture. So this is important before we dive into the devices part. So next it would be connecting devices and the user journey involved in there. And followed by that, we have 3 demos. So that are interesting with some of these devices. So this is a quick recap. What are the product offerings from us? So we are coming out with a powerful combination of a low-code IoT platform that is targeted for system integrators, enterprise developers, and like that, and also vertical solutions that are targeted for industries. So this combination would accelerate the IoT deployments much faster than ever. And so what kind of platform do you offer? So this is a low-code, highly secure, enterprise-grade platform that comes with hundreds of devices support out of the box. It can process and store billions of data points. It has real-time data visualization through dashboards, analytics reports, and also it has AI-powered analytics and predictive maintenance capabilities, and also integrations with some critical applications like CRM. Right, so these are all the portfolio of IoT solutions that we are focusing on. So number 1 is industrial IoT for smart manufacturing, and number 2 is smart buildings and energy management, where we provide unified operation and maintenance suite. And then third is connected products for OEMs, so who can make their appliances, hardwares, vehicles as connected products and sell to the customers. And number 4, these are discrete point solutions. It could be a vehicle tracking application, waste management, smart lighting application, solar monitoring type of application. So these are all the areas that we are also focusing in depth. And with that, let us get into this IoT technology stack. So understanding this technology stack is very important for anyone who wants to work in this IoT domain, want to develop or deploy solutions. So these terminologies and these concepts are very important. So let's all begin with, and this includes multiple layers of hardware, software, and communication technologies, so that all these objects become connected over the internet. Right, so it all starts with the assets. Right, so here these are the critical infrastructure or the equipments that has valuable data. Example, machines, appliances, vehicles, patients, buildings, anything. Right, so that generate valuable operation data that requires monitoring and control. Number 2 are peripheral devices. So these are majorly sensors that are capable of capturing various parameters. It could be electrical parameters, it could be mechanical, physical, chemical, all these properties, temperature, humidity, and all those properties, and also controllers and actuators which are used to control some of the pumps, motors, heaters, lights, and all that. And most of these the peripheral devices or will have a low resource footprint, and they'll not have direct internet connectivity, and they will also be having low power consuming capability. So much of these sensors will also run on batteries. So these constraints are required to make it more economically feasible solution to deploy in multiple places. So to address the gap where it is not, since the sensors are not able to directly connect to the internet, so these sensors provide some local connectivity options through wired mechanism or even wireless mechanism. So these mechanisms through wired, for example, it could be Modbus, which is an industrial communication protocol, which is used in factories where these PLCs and pumps, meters are all connected, and in certain smart city or smart building use cases, wireless technologies are also used, something like which works on radio frequencies like LoRa and Bluetooth, other things. And all these technologies and sensors, the choice depends on lot on the deployment environment factors. So it could be, whether are we deploying this indoor or outdoor, whether we need short range communication, whether we need a long range communication, whether that technology has indoor penetration through the radio frequency signals, or whether there is a line of sight accessibility to those signals, and all these factors decide so what technology to use and what sensors to be used. So next one would be the gateway hardware. So these are the equipments or hardware that has the connectivity to those peripheral devices, which are sensors. It could be through wired mechanism or wireless again. So here hardware devices has the connectivity to the internet as well. So it has both the southbound as well as the northbound connectivity. So the northbound, what I mean by northbound is the connectivity to the internet, and southbound is connectivity to the peripheral devices. And these gateway hardware are the places where the software needs to run on. We call that software as edge here. So these edge software would be running inside these gateway devices, which are capable of collecting the data from peripheral devices and processing it, filtering it, and transferring securely to the cloud. So the next one is the edge to the cloud connectivity area. So this is the typical internet connectivity which can happen through IoT M2M SIMs or 4G, 5G networks. It could be Ethernet, Wi-Fi, or even satellite or NB-IoT, all sort of communication ways, right? And these are the internet communication ways. However, the protocol that is being predominantly used for IoT communication is MQTT. This is most preferred protocol because this is a lightweight publish subscribe based protocol, and it has, unlike HTTPS, which is request response, which is heavyweight, and this protocol MQTT is designed for unreliable networks that has low bandwidth or high latency type of environments. So the next one would be the cloud platform. So this is required to process, or authenticate these multiple device sessions in a secure way, handle the real-time data in a stream processing, and process the alarm rules. It has to store huge volume of data and have to visualize them, and also has to hold all these functional modules like devices, assets, users, and all other application modules. And the cloud applications are those vertical applications, the end user facing applications that we build on top of the platform. So this summarizes the entire IoT technology stack. Let us try to apply that few use cases here so that it becomes more clearer. So for an example, like a chiller energy monitoring use case, here the asset would be the chiller, and the peripheral device, for example, here we are monitoring the energy, and energy meter is a peripheral device that is retrofitted on along with this chiller. So they capture the energy data, and the energy meters here will not have direct connectivity to the cloud. So there is a wired communication through Modbus RS485 cable to the gateway. So the gateway handles is able to hold the edge software inside it. The software collects the data from these energy meters and pushes to the cloud. And it could be based on Ethernet or Wi-Fi or SIM card, and then it reaches the cloud and then the cloud application. So similarly, this need not be the same what you saw on the first four side. These four components even can be composed inside one equipment. That is when we call that as a smart asset, right? So for example, in AC that we see air conditioners, we call them as smart air conditioners because the asset has the sensors, it has the connectivity and the gateway capabilities inside it, and it is able to communicate directly to the cloud from that. So that's one example. And the other use case is consumer use case. Even we could apply here. So and even here the asset need not be always a machine or something. So in this particular use case, the asset is the actual person who is wearing the wearable, right? So that person is the asset, and we are interested to know the parameters of that asset through this wearable device. So the peripheral here is the wearable that we have, and which measures your heartbeat and steps and a lot other parameters. And these wearables will not have direct connectivity to the cloud, so they have a local Bluetooth connectivity with your phones, smartphones. So the phones will hold the software or app inside it that is actually equivalent to an edge software, so which is capable of receiving those data and pushes that. So similarly, we could apply this to any of those IoT use cases. So the fundamental technology stack remains the same. So with this, let us enter into the Zoho IoT modules and architecture. So this is the overall architecture, this is engineering way that you can see the left side is devices and the edge software capability, and the right side is the cloud capability. So within the cloud, as I was explaining even in the last overview presentation, that the architecture, while we architecting this platform, we had taken three main factors. One is scalability and modularity and real-time responsiveness. So here, this architecture enables us to seamlessly scale to accommodate growing number of devices, huge volume of data, and also dynamic workload scenarios. And here we have a service called IoT Message Hub that manages bi-directional device communication and authentication and provisioning queues and things. And number two is stream processing engine and service, which ensures that the data gets processed in real time. It be able to detect any anomalies in the event, the data telemetry that we receive through alarm rules. And we have a big data storage engine where all these time series data gets stored. We have an app backend engine which is centrally is used to manage all the devices, assets, alarms, users, and all others. We do have a structured database to maintain these modules and custom modules that are built. And over and above this, we have lots of builder capabilities. And over and above that, we build vertical solutions like industrial IoT kind of solutions. So with that, let us zoom in on the backend side here. So these are the core functional modules. There are other modules like dashboarding, analytics, user management, and other modules which are common for any kind of applications. Whereas every application has some of these core modules. So here with IoT, if you see manageable entities, this remains as a core module. Like here, the devices, the assets, the locations, which are like spaces, like building and other things. So and then you can also define custom modules over and above this, which could be, say, tariff could be one custom module, or an inspection process could be another custom module sort of thing. Whereas here the manageable entity modules will hold sub-modules like for monitoring and control. Every single module here. So under devices, you can create multiple models for each of the purposes. For example, Under assets, you can model something called as a chiller as an asset model. Similarly, a diesel generator could be an asset model, a CNC could be an asset model. And individual these models can hold data points, they can hold alarm rules, alarms, commands, this can have individual template dashboards and things. And all these will have metas fields as well in addition to that. And for today's presentation, we will focus on devices, because the devices are the core backbone for IoT, because that is the way through the data gets streamed, and we build all the user experiences around the devices module. So before getting into the screens about devices at a high level, so we have two different portals. One is this end user application portal. So that is targeted for the facility administrator or your production manager in a factory. So these are end user applications, and these are the places where we have dashboards, reports, alarms, and other things. And number two is the developer portal. So this is designed to empower the system integrators, developers to seamlessly customize, define rules, automate and things. So all the customization experiences happen through the developer portal. So let us go into the connecting devices user journey. So first part of that, or the first stage, would be adding a device. So, and then number two is onboarding the device, and number three is customizing the device. So when we talk about this connecting these devices in this IoT world, this may sound very technical aspects, but actually if you see, it is quite similar to what we do often, which is taking up flight, right? So which is like adding a device is similar to getting a visa or booking a flight ticket. So where your devices gets an identity and it gets registered and it is ready for the journey. So that is the first stage. And number two is device onboarding is similar to we arriving at the airport, doing the check-in, and then boarding, going through the security check-in process, and then doing the immigration activities and things. There are different steps or stages involved in the immigration and check-in process, right? So that is what we call that as device onboarding. And the third stage is customizing the device. This is the most fun part, which is like actually flying, right? So here we while we are inside the flight, so we have all the comfort and privileges to adjust our seats, define, set our preferences, order a meal, and a lot of things. So similarly, when the device gets added, you get the permission to adjust the device behavior, configure the dashboards, reports, and all that thing that fits your needs. So with that analogy here, so we can enter into the device addition first stage. So here the devices are listed in your end application in under the devices menu, and in devices menu you would also see other submenus like certificates and policies. These are for secure authentication. These client certificates and authorization policies are defined for the devices as such, and you see add device button on the right side. And once you click on the add device, there are a few options to add the devices. So number one would be adding using the product gallery here. So the product gallery is the place where we showcase all the different category of devices that I was mentioning in the IoT technology stack slide. So where it could be gateways, you can filter them, like what are the gateways, what are the peripheral devices, what are the smart sensors that are there. So you can have a smart filter based on these technologies, or by manufacturer, or by use cases. So this lets you to explore the devices that are officially supported and tested inside our lab or even in our customer environment. And So for example, here when you take up adding a gateway and a peripheral device, which is, let's take an example of adding an energy meter. Here the energy meter would be a peripheral device and the gateway is here, and this has to, the gateway is the one that has connectivity to the cloud, and that is the reason we need to register that in Zoho IoT. So as part of this addition process, so we select a gateway. So you choose a gateway and then it will get up a form, give you a form. So where you could choose the protocol. MQTT is the, as I mentioned, there is a publish subscribe mechanism. So here you can choose that as the device connectivity protocol, and there are various authentication types. One is security token with TLS. So the next one is client certificate, which is for advanced, authentication purposes and encryption purposes. And number 3, security token without TLS. This is not recommended approach. This is only required only when you are using very much constrained devices, which doesn't have the capability of encryption and sort of things. So for industrial deployments, we can remove that option from the settings. So once you register this, you will get all the MQTT credentials. And next step would be you will be adding this peripheral device, which is an energy meter. So here what you will do is, you can see there is a peripheral protocol, which is Modbus RTU here in this case, and there's a menu for picking your gateway here. So this is the place you associate through which gateway this energy meter is going to send the data through. So earlier we added a gateway, so that is the gateway that you will associate for this energy meter. So once that is done, so you would go to the next step. Before that, so I'll also show why are we listing these products inside our product gallery. What exactly are there behind the scenes inside the product? You can see this list of all the products that you see on the product gallery page under here in the developer portal, the products menu. So there will be a list view. You can drill down, you can view, for example, in this energy meter, a Schneider energy meter, we have listed out all the data points that this particular sensor is capable of exposing, right, or collecting. So we also have mapped the low level protocol information within the product. So for example, under actions, you can find Modbus registry mapping. So we would have given all that inputs that are required to collect the data from this energy meter, where the Modbus addresses are given in this space. Right, so this is the real value add that we do by showcasing or listing those products in our page. So once this is done, this is just the addition process. Now I'm not taking you through the onboarding process. I'm going to shift to the next category of adding the devices. So next, which is a smart sensor or a LoRa smart sensor. So in LoRa smart sensor use case, so there will be different kinds of LoRa sensors. It could be indoor air quality, a temperature sensor, any of these sensors. And in this particular technology, the gateways are in wireless way, and the gateways are capable of receiving these signals from any of these LoRa sensors. There is no kind of one-to-one kind of mapping that is required in this particular technology. Any LoRa node can broadcast the message, and the gateway can receive that and relay this message to the LoRa network server. So the gateway will be configured with the LoRa network server to which it has to propagate to, and the LoRa network server is the place where these LoRa nodes are authenticated, and there is a network server that handles the unique IDs of these LoRa sensors. We call it as dev EUI. So that is the parameter that is required to uniquely identify every LoRa sensor. Right, so from the LoRa network server, the encoding, decoding, all those things will be happening over there, and the process data can be forwarded to the IoT platforms. So in our use case so far, so in our platform so far, so we are compatible with third-party LoRa network servers that are available in the market, and we are also coming out with our own LoRa network server soon, and we'll be launching that. So here, when you get into the data streams, that is where we have listed all these LoRa network servers that are third-party LoRa network server services. So you can go ahead and choose one of that, and whichever that you have an account to. So you can create a data stream where you get the data stream gets registered, you get an endpoint URL and the stream token. And similarly, then you would add this LoRa node, which is a smart sensor here, which is an IAQ sensor, for example. It's a mile site sensor. You would define that the dev EUI, which is an hexadecimal 64-bit thing, and there is a data stream. This is the place you would relate this LoRa network server that you have added in the previous step. So once this is done, so your registration process is all done. So next one, that as part of adding the devices, so the next option is defining your own device product. So this is the section where when you don't see your product under our product gallery, it doesn't mean that the platform cannot support that, right? So this is still compatible with the platform as long as it follows all the standard ways. So we are continuously adding lots of these devices in our product gallery, so to make sure that their formatters and the encryption mechanism, the data points are all preloaded for you to do that. If that is not available there, you can also go ahead and add your own device product. So similar way, you can choose whether it is a gateway or whether it is a peripheral sensor or it is a smart sensor, and then you can define the formatters by yourself. You can define the data points that are mapped in that device by yourself. So by that way, your product will also be listed under our product gallery, and that will be reflected only inside your workspace. That will not be reflected to the entire world. So that will be there inside your workspace, and you can go ahead and add those devices multiple times. So number 3, so this is the way where you define API endpoint, direct API endpoint. These are not necessarily devices. This could be any even some software system that is running, so you can stream the data from there to our systems. So this could be running on a PC, or it could be running on an industrial gateway or wherever. So you already have a third party way where you have an MQTT client. You want to push that data to us. Still, you don't have to go through our product gallery. You can go through this. So you can just define API endpoint. Again, this will ask you what is the mode of operation, and then even you can send this stream the data through our HTTPS endpoints as well. For example, if you are you want to stream some weather data that you want to ping from your weather APIs and push it to this application, you can do that through this kind of HTTPS mechanism. Here for HTTPS, we ask information about data interval. Since HTTPS is not a live long-lived connection, so it is based on a request response kind of a layer, so we will not be able to identify whether that connection is actively connected with that or not, right? So for that, we have a periodic monitoring interval. That is what we had mentioned here. So if you are not connecting to us in 15 minutes, for example, in this case, we would consider that particular connection is offline. So that for that purpose, we ask this extra information for HTTPS. So once these different types of devices are added, so you get this, congratulations, you have successfully registered the device. And once you get into the device details page, you can see the actions menu. You can see a connection. This is your actual visa or your ticket for the journey, right? So this is the next stage now, which is device onboarding. So as I mentioned, so here this is the stage where it involves multiple steps, right? So before that, we offer the users to see, go through two ways. One is that if you have an IoT device, you can go through this mechanism, right? So this will lead you through a wizard approach where we will take you through different stages there. Second way is that if you don't have a device but you still want to evaluate, understand the concept, and then build a prototype, you still can do that through our simulators. That is also another onboarding stage that we help you through with. So here we are just focusing on one use case here, which is onboarding MQTT gateway through Zoho's Edge application. So when you are doing that, there are going to be 5 stages inside here. So number one is prerequisites. So where we give the information about installing and configuring this edge agent in your gateway, right? And manage them there. So this is the first prerequisite. So we give the installation guide, there are documentations. We are also exposing now the option to download these agents from our documentation page. So there are instructions to install them there. So these are all the types of the edge software that we provide. So one is Edge SDK. So these are it comes under C programming language, Python, Arduino, and we also provide a plugin on top of a Node-RED. If you're a programmer, a Node-RED programmer, then you could find the Zoho IoT plugin, so and then start using that. So these are for targeted for OEMs or do-it-yourself kind of person who wants to build on top of our Edge SDK. Number two is Edge Lite. So this has some of the Modbus protocol capabilities and real-time data collection from these meters and other equipments that supports that, and securely transfer that to that cloud. And number three is the industrial core, Edge industrial core. So this is targeted for manufacturing industries, large buildings. So where we support a lot of protocols, and it can be deployed in industrial PCs and industrial gateways. It has a more functional framework there which can be extended on top of that as well. So here, these are some of the key differences between these edge softwares that we provide. The SDKs are targeted for developers and OEM solutions. Edge Lite is for quick start, do some pilots in collecting metering data and things. And industrial core is for large scale OT, IT teams, large enterprises, which supports a lot of protocols like OPC, UA, BACnet, Siemens, SQL, a lot of these protocols, and these all have MQTT capabilities inside that. So this is the first step, installing the edge software. That is what I mentioned as the prerequisite. Number two is now connecting with the platform, right? So for that, in this stage, we show all the credentials that are to be entered into the MQTT side. So this has broker URL, the broker port, the client ID, device ID, the username, their password, or the token information, authentication token information, MQTT versions and things. And once this is being configured on your device and started, you will immediately see that this will be from the listening mode, it will turn now to device successfully connected mode in the second stage. So that's when you will be proceeding to the third stage. Here you would see the edge agent configurations. Now we have made a live connection with our edge application, but we need to configure the edge to collect the data, right? So for example, in energy meter use case, we provide interfaces where you define the Modbus configuration of the energy meter. What is the slave ID of that energy meter, right? So you can configure them. What is the baud rate? What is the serial port information? So all that information can be configured in this third stage. Once this is done and saved for one energy meter, this gets added. Number 4 would be now, with this configuration, the edge would restart and start collecting the data from the energy meter, and that is when it will start streaming the data here to the platform. So that's when you start seeing these live messages in the fourth stage. So where you would see all the JSON messages, could be energy meter, and what is the parameters like reactive power, voltage, peak demand, all that information would start be coming inside the platform. And since these energy meters are officially supported as products inside our platform, we already have defined the parsing rules for that. You will automatically see that the data gets parsed, and the data gets you will get this green signal where the data point has been parsed successfully and stored. So that's the end of your onboarding process. So now we are ready to actually fly and customize this the device under the device dashboards and things. So far we had seen these two stages. I'm not going to touch on the customizing the dashboards, or how these data points parsing rules have been defined if you need to define. So those are the things that we would address in the next session. So for now I'll stop here, and we will have a demo. Whatever that we saw in the stages, we will see that with the 3 use cases.
Let's start with a demo. So previously we see how to create the device and how to onboard the device. So now let's start that part in live. Okay. So in this scope, we'll see the create device and programming device and connecting the device and how to configure those devices. And creating alarm commands will be continued in further sessions. So let's start with small use cases. Okay, cold storage monitoring. The cold storage will be mostly used in food and medical industries. And food, they will store the fresh milks and the fresh meats, and in medical industry they used to store the vaccines and all those medical equipments in critical temperatures. So in current section we will see how to monitor the real temperature and humidity, and the alert and the remote control will be carried on further session. So let's start with a small connection diagram. This is an ESP32, which is the Wi-Fi connection inbuilt, and it's mostly popular in DIY community. And there is a temperature sensor, which is DHT11, which can able to collect the temperature and the humidity. Also, we have the relay to control the AC. So let's go and add the device. First, I'll go to the devices. Since we covered the adding device part, I'll just go to the device directly. So once you go to the device, you will get the pop-up how to onboard this. Since we got the device, we'll just click next, and just I'll close this. So, and this is a smart device, so we'll go connection step directly. And so ESP32 is popular with an Arduino IDE. So once you go to an Arduino IDE, you can find the library manager where you can find the default library. If you search for Zoho, we can find the list of available libraries. So it's got stuck. I'll just open the Arduino again. Yeah. So you can find here that Zoho has an library predefined in Arduino, so you can directly install it. Since I already installed it, it's mentioned as remove. So once you install it, we can go to file examples, and to come bottom we can find the Zoho IoT examples. In these examples, we covered like a lot of basic things, how to onboard ESP32, ESP8266 in different security modes, as we mentioned in previous slides, TLS and TLS-A, and also the non-TLS part. So I'll choose DHT with relay. So once you choose this code, what you need to do is you need to update your Wi-Fi credentials to add to the internet, and also the username password, which we can get from the page, the username and password. So I have already connected the username password. Just I will add the device, connect the device to my laptop. So just go to the port and wait for this to come in. Sorry, it's not showing. Just I will reopen the Arduino again. So I can find my device here. So just open the serial monitor where you can debug what are the status of the devices. So you can see here it's just connecting to my Wi-Fi, and then it's mentioned ready. So if you go to our app, we can see the device is connected. So if I click proceed, we can wait for the messages. So the gateway by default will hold the temperature and humidity and send every 10 seconds. So as you can see, we got the successful image. So next, similar will go. So you can see the data is get paused. So these are the steps how you can onboard an Arduino or ESP32 device in our cloud. Okay. So now we can go to the next level, which is an Raspberry Pi. It's a microcontroller, so you can do a lot of processing, and we have a lot of room to play with the message what we get. So in Raspberry Pi, it's a simple process that you can connect the RST sensor to that Raspberry Pi, and also we have the complete guide how to program, how to flash the Raspberry Pi OS, and how to create an account, and how to connect the sensor. So I just already connected, so I'll just go my device. Okay, so I'll just go to the Raspberry Pi device. This is my device, and just I will start onboarding. So same case here, just you need to copy the username and password. So this is my Raspberry Pi which is connected to my terminal. So inside this we can find a lot of examples. So there is an example, the DST sensor, which I have already created the username and password, updated. So once you run the program, you can see the device is connected, and then if you go here, you can wait for the next message to arrive.
In the meantime, you can show that these steps are there as part of the help documentation.
We can find all those steps, how to connect the OPI, all those wiring diagram, and how to register those devices and add using your models. Also, I can see all those details and where you can clone the project and how to install. All those steps will be covered in our document. So we will go back to the device. You can see the messages started coming. Okay, so this is how you can onboard like Raspberry Pi and Arduino with simple use case like temperature and humidity monitoring. So these are the SDKs and these are the examples Raspberry Pis you can add. Now come to the next use case. This is an industrial use case, energy management. Okay, in industries, the energy plays a major role. Each and every devices in the industrial force consume energy. So monitoring it continuously is a key parameter in optimization of the energy usage on those things. And also the energy monitoring report, which will get really helpful during an yearly annual audit of energy, where our factories will stick to the compliance standard that is provided by the industries and the governments in that particular area. Okay, so now let's start to onboard on device. Before that, I'll show this setup here with my camera. Just I'll switch camera to USB. Hope you can see here, right? So this is an energy meter which is used in all our offices and also the industrial purpose. This is a standard based model. You can see the voltage. This is a 230 volt. So it's in inverted mode, but this is the voltage. You can see it's 230 volt here, and this is connected to a gateway, which is an Teltonica gateway. This is used probably used many by European countries where everyone is using the Teltonica. So we are also using those models everywhere. So let's start onboarding this. I have already created the gateway, so let's start onboarding. Okay, please follow this installation guide which we have already installed in our gateway. So I'll just go to proceed. Now I have the username and password. Please copy these, and we have a local interface inside the Teltonica. I'll just log into that interface. So I have already copied and pasted username. I'm just turning on this. Okay, so once you started, you can see the device is connected. Now just give proceed. So I need to configure this energy meter. So just create configuration, and then I will give update configuration. So go to this, and I'll already configure. So just I will go through it. Okay. So currently the energy meter is connected by RS-485. We also have the Ethernet, which is a Modbus TCP. And in RS-485, these are the settings which need to be used. This is a port in which the Teltonica RS-485 is connected. This is a 30S1. And these are the parameters used in Modbus terms, like what it is the speed, how much speed it need to be transferred. It's like 9600 bits per second. And the parity is like how to identify the stop bit and end bit. All those things are in Modbus parameters. And we have the Modbus RTU protocol which we are using. So just queue next. And the product, we have already created the product. So we can choose a lot of products available. So it's an EM64NG which we have already created. So I'm choosing that product, and I'm just giving the name to it. And the slave ID. In Modbus, we can DC chain like multiple devices, up to 30 devices we can DC chain. So we need identification of each and every devices. Like if I energy meter 1, this is a 1. If I have an AHU, energy meter for AHU, I need to identify as slave ID 2, all those things. So this is slave ID 1. And this is a timeout, how far the data need to be transferred, waited for the data, all those things. So just I'm not modifying that. Just I'll give next, and I'm not updating anything. Okay. So once you deploy it, it will transfer this configuration to the gateway via our cloud. So you can configure those things from the remote. You never need to go to the site for doing any changes or adding extra meters. All those things can be done from our cloud. So once you've done, so it will wait for the messages to come. So let's wait for some messages. So in meantime, you can also see the logs, whatever going on in our app. So all those logs, whatever the reading, all those things, you can find it here. So you can see the messages started coming. So if we give proceed, since this is a gateway, we are connected to a peripheral sensor. All these data points will be in the related thing. So you can find the active power and the phase voltage from this gateway, which is get passed here. So this is a basic thing. So in case if you need to add some configuration, add some computation in edge, you are also providing the scripting option. So where you can modify the payload whatever you need, and also there is a DB support. We need to store it, like you need to send average of 1 hour data from the edge itself, not handle it in the cloud. You can do it as well. You need to calculate the delta, or need a timer. All those things are available from here. So you can basically add the script which can message handler. This will hand the payload once you given, and then it will be published to our cloud. So all those thing modifications can be done from your side itself. So this is how we can onboard the industrial gateway. This is an edge Lite interface. I'll just go through this. So home, basically you have the username, password. We have this TLS as well as the client certificate, where you need to choose the extra certificate for double encryption support. On the logs page, you can see what are the currently happening, and static log is the complete log from where it's booted, all those things you can see. On the script editor, you can see like when how to get the message. Once the message came, you can see here. If I need to publish it now, or I can collect every 1 second, I can publish in 1 hour once by calculating the average or delta. So if you want to log something, the calculation parts, you can use the logs. And these are the contacts, like for the piston storage, I need to store it and then I retrieve it after the next message. All those things can be used for these contacts. And the timer is like I need to publish after 10 seconds, so I need to keep track of timer. So I can set the time and then get the time, how much time it's happened between the next script on those things. And DB is an SQL database where you can insert your data and you can execute the query. All those things are supported. And we can also control the commands. Like I need to locally control my commands. Like if the temperature is breaches, I need to send to the cloud, and from the cloud I need to control it. If it's a really critical thing doing a fire alarm, we need to turn on the wall locally instead of relying on the cloud, because the network might be get slow. So all those things can be done internally here itself. So these are our edge Lite, and this will support in multiple devices, Teltonica, Raspberry Pis, and we also have the Dockers to run on any systems we want. Okay. So now let's go to our presentation.
Just to add here, the Edge Lite page that you see, so that is not a cloud application page. So that is something we are connecting directly to the gateway. So you can find that IP, and the server is running on 8070 port.
Yes.
So this is not the cloud version. So we are connecting to the local web server that is running on our edge, and we are configuring over there. And yeah, go ahead.
Yeah. So that's it. We can configure. Once we configure, everything can be done from remote. We never need to go and touch the device again. Okay. So now let's go to the smart office. In smart office, indoor air quality matters the most. Okay. So indoor air quality directly affect the user performance and how they feel and how comfort are they. Okay. Like CO2, PM 2.5, the temperature, humidity, all those monitoring will help the office to manage where there is a lack of airflow, or where the ventilation is needed, how the HVAC is need to be optimized, all those things. So using IAQ will use the LoRa to onboard it. That's a straightforward. We already have the direct integration with a lot of LoRaWAN providers like Helium, ThinkStack, ZipStack, Senet, all those things. So currently I'll go with the Things Networks, TTN. So you can see here the gateway. So this is a Things Network interface. So currently the gateway, you can see what are the gateways it's already connected. So this is the gateway which we have connected right now. So this is a mild side. And in applications, we need to add the devices. So you can see what are the devices I have added. So these are the IAQ sensors like AM619. These are from the mild side devices. So this is a 619 AM619 devices. Inside this, there will be a dev ID, which is an unique identification for this device. This will be standard across all the devices, like a MAC address for an LoRa based devices. So once you come to our app, first we need to add the data stream, which is already covered in the previous slides. So this is the TTN network which we have already added. So if we go to these details, sorry, I'll just go to new one, things network. So we get this endpoint stream, which need to be added here, the webhooks. In webhooks, you need to add those endpoint stream. Once you added this, all the data coming from TTN will be forwarded to our Zoho IoT. In Zoho IoT, once you added the data stream, you can go to the end application. In device, by default, we have the AM319 sensor. So we can add those sensors directly. You can see the messages start coming here. So that is a straightforward integration. Now that will be not much complex step to integrate our LoRaWAN server in Zoho IoT to our LoRaWAN server. So you can see the data. These are the data forward from our TTN to the Zoho, and these are the data points like HT, CO3, light level, CO2, and PM2.5 sensors. So this is how you can add our LoRa device to the gateway.
So this is an area where we just covered, to connect and onboard a basic device. Whereas when you enter into enterprise scale deployments, there's going to be huge number of devices, that too multi-vendor devices, multi-technology devices that are used for the same purpose, right? So for handling all that use cases, so we do have ways where we do have model concepts, we do have product segmentation concept within models to handle multi-vendor, versions and things. And over and above that, we will look into how to configure the data points, how to import the data points efficiently, and also use them to define in dashboards, as well as creating alarm rules and things. So these are all the things that we have planned for the next session.